Good morning to all. Today we can discuss about the basics of cellular concepts in wireless communication. The cellular concepts, the basics which cover how the cells are distributed, how the base stations are arranged, and the next thing it considers how it is going to make the coverage region. These things we are going to discuss in this particular topic. So first we have the cellular structure, how the cellular system is going to be uh, defined. So how the cellular system is defined, the major objective is how to achieve the very good coverage without any deviations in your cellular concept. So first, the cellular concept is for the given set of frequencies can be reused without increasing the interference, and the large geographical area covered by a single transmitter can be divided into several sub areas. So this is in our country, we have a very large geographical area. We are going to divide this our country as some small areas, and each is allocated with some set of frequencies. With a small geographical coverage, lower power transmitters with low antennas can be used, and the group of cells that uses different set of frequency we are going to use a cluster. So this is the clustering. So this we are going to the small coverage area with the base station, and the shape of that particular cell can be of circle, square, equilateral triangle, as well as a hexagon. But the commonly we are not going to use the other structures like circle, square, equilateral triangle, because it doesn't have the much coverage as you have in the hexagon. Because hexagon is having 6 sides, so we can form 6 adjacent cells compared to the others. So circle can only have 3 adjacent cells, square can have 4, equilateral triangle can have 3. But in circle, there are some coverage area which is indicated in yellow color will be having not covered at all. But the remaining 2 can be covered, but we have some smaller number of core channels, so we are not going to prefer that condition. So hexagon is the preferred one. So the real footprint is irregular. The regular shell shape is needed for the systematic study. We are going to use these structures, but we are going to prefer only hexagon because of these reasons. Because the reason for choosing the hexagon is major thing is its coverage regions we have, and 6 core channels we can have. And in this hexagon, we are going to deploy the antenna, that is the base station antenna, either at the edges or at the center. So based on this, we are going to divide it as 2 things. One is center excited cells and the other one is edge excited cells. The base stations can be placed to the center of the cell. So in this case, we can use only omnidirectional antenna, because the omnidirectional antenna can only transmit towards all directions uniformly. And the second one should be of edge excited cells. The edge excited cells, each of the edges will be having or vertices, their particular antenna can be located. But only thing is it can use sector directional antenna, because it has to point towards any one direction. It doesn't want to cover all the areas. So we are going to use only sector directional antennas. Example for a sector directional antenna, we can say the horn antenna is one of the example. So we are going to use that cell, the coverage area of the particular cell is considered to be the footprint, and how it is going to distribute the frequency in each channel. So we have taken one of the hexagon structure. This is called as one cluster. Okay, so the one cluster, so it is a 7-cell architecture. Here we have how many cells around the single cell? We have 6 core channels which are formed together. So we are going to group all these to be a cluster, and each cell of each cluster will be allocated with either the particular antenna can be placed at the corner or center excited. So there are n number of cells, n with the cluster size. So what should be the cluster size here? 7. And the number of cells within each cell is allocated to a group of K channels. So the n cells in a cluster would then initialize all K channels, and n is also referred to as the frequency reuse factor. So the total number of available channels used should be, so S is equal to K into N, because it is the product of the number of cells and the initialized number of channels. So we are going to allocate each and every distinct frequency to each cell in a cluster. But the same cluster can be formed at another one thing. So we are going to use the same frequency for that cluster. This process of selecting and allocating channel groups for all the base stations within the system is called frequency reuse, or we can say it is frequency planning. So the collective number of cells using a complete set of available frequencies is called cluster. So in a cluster, you have some 7 cells which are having some K set of frequencies. So I told you S equal to Kn. So what should be the collectively the capacity? The capacity will be, if you have m number of clusters, m is equal to capacity is equal to K, m into K into N. So the cluster size will be, the N value can range from 4, 7 or 12. The cluster size N is reduced, then the cell size is kept constant. More clusters are required to cover a given area. So the frequency reuse factor is given by 1 by N. And what are the core channels? So see here the cell 1, cell 1, cell 1. We are calling it as core channels, which are located at some distance. Two cells using the same set of frequencies, we are calling that as core channel. And what is the core channel reuse ratio? It is given by 1 by N. So the minimum radius of D by R that is required to provide a tolerable level of core channel inductance is called as core channel reuse ratio, where D is the distance between the two core channel cells and R is the radius. So which is equal to root 3 N, which is the cluster size. How to choose this particular core channel, or how to choose the particular core channel is given by the cluster size equation, which is N equal to I square plus Ij plus J square. The parameters I and J are the measure of the numbers of nearest neighbors between the core channels. So typically we have I equal to 2 and J equal to 2 for N equal to 12, and for I equal to 3 and J equal to 2, we have this I square is 3 square is 9 plus 3 2 is 6, 15 plus, so J square 4, so 15, 19. So likewise, it is going to formulate. What should be the cluster size for, if the value of N is 7, I is equal to 1 and J equal to 2, or J equal to 1 and N equal to 2. So how we are going to locate is, there are 2 steps. So for example, here 4, how is located? So move I cells along any chain. So we have a cluster size here N. So N equal to 12. So I equal to J equal to 2. So from 4, it is moved 2 cells. So from move 2 cells any direction means, for example, the center, it is going from 4 to 1 to 7. So 2 cells, second cell is 7. So then from that, you have to turn 60-degree counterclockwise and move J cells. So 60-degree counterclockwise means it is moving towards 12. So 12, then 4. This is how the core channels are located. So this is nothing but the steps in designing or to find the nearest core channel concepts. So this is the basic concept, how to choose a cell, or how the cell size should be, or the shape should be, and how the frequency reuse is going to be implemented, and how the core channel is located. So this is some of the basic principles of your cellular system. Thank you.